Hello everybody and welcome to yet another math video. In this video I will be going over exactly 2 examples of using the simplex method to solve some real-world situations. Let's begin. A department store has $24,000 to spend on television advertising for a sale. All ads will be placed with one television station. A 30-second ad costs $1,000 on daytime TV and is viewed by 14,000 potential customers. It costs $2,000 on primetime TV and is viewed by 24,000 potential customers, and costs $1,500 on late-night TV and viewed by 18,000 customers. The television station will not accept more than 15 ads in all 3 time periods. How many ads should be placed in each time period to maximize the number of potential customers? And finally, how many potential customers will the ads reach? All right, the first thing we need to do is define our variables. And in this example, there will be 3 of them. The first of which I will call x1, the second of which I will call x2, and the last of which I will call x3. If you've seen my other video, which I will link down below, about how the simplex method works and how it's related to linear programming, you will know that I used these variables before, but if you are learning this in a different forum, you can, and your professor or teacher uses X, Y, and Z, feel free to use X, Y, and Z. So here are the definitions of the 3 variables. So we will have the number of daytime ads, the number of primetime ads, and the number of late night ads. From here, we need to figure out the objective function, and we are trying to reach the most number of potential customers. So the objective fund here, or the objective function here, will be about the potential customers. So we will have P equal, let's see, for a daytime ad, we will use X1, but for each daytime ad, we will reach 14,000 potential customers. So 14,000 X sub 1. You can reach 24,000 potential customers for each primetime ad, and you can reach 18,000 potential customers with each late night ad. From here, we want to create the system of inequalities that we call the constraints, or the I system. So we'll call them the constraints or the I system. All right, so what are we being restricted on? We are being restricted on the number of ads that can actually be placed with the television station, and we're also restricted on how much money can be spent, this $24,000. So let's see here, we can say it is $1,000 for each daytime ad, $2,000 for each primetime ad, and $1,500 for each late night ad, and you cannot spend more than $24,000. As far as the number of ads are concerned, we have X1 plus X2 plus X3 has to be less than or equal to 15. And then, of course, you want to make sure you write these down, even though they do not affect the E system, nor do they affect the simplex tableau. You still want to write down the non-negative constraints here. The final thing that I will be doing on this particular slide is changing each of these inequalities into an equation by adding a slack variable and including this objective function in the E system. So here are the 3 equations that we will use in the simplex tableau. On the next slide, I will write the simplex tableau that is represented by these three equations, and we will get to finding pivots and simplifying the simplex tableau. All right, we're starting out this slide with the simplex tableau of the E system from the last slide. The first row represents the inequality with the slack variable for the cost of each ad. The next row equals the number of ads that are allowed to be purchased via the television station's rules. And the bottom row is the potential customers that will be reached by the ads. So the objective function in the bottom row. All right, so again, the process is we have to find the most negative number in the bottom row, and that is right here. So this will become the pivot column. So then what we do is we come off to the side here, we divide the last element in each row, so 24,000, by the element in that row in the pivot column. So this is divided by 2,000, which is 12. And then in the S2 row, that is 15 divided by 1 is 15. And we're always trying to pick the smaller number here, and the smaller number here is 12. So the pivot row is this row right here. There we go. And where those two things overlap, that is the pivot. So our pivot here is the number 2,000. And what we try to do, or not what we try to do, what we will do is change that 2,000 into a 1. And to do that, we take the row S1, we divide it by 2,000, and we place that result back into S1. So the new simplex tableau looks like this. From here, since this is the pivot still, we need to get zeros underneath this. So I want to turn this into a 0, I want to turn this into a 0. So what that means is I will have to do some row operations, and remember, row swaps are off the table. We cannot do that. So we will take -1 times S sub 1, add it to S sub 2, and then we will place that result in S sub 2. That's how we will get a 0 there. And we will take 24,000 times S sub 1. We will add it to we will add it to row P, and then place that new result in row P. And when you do those two row operations, the new simplex tableau will look like this. Ta-da! All right, so with this, you can see that row S2 and row P changed. But more importantly, I'm going to come back up here. You can see that the column under S sub 1, that's here, shifted to be under X sub 2. So X sub 2 was our entering variable, and X sub 1 was our exiting variable. So S sub 1 exited way out of this column. It's not even in this column anymore, and X sub 2 entered into it. All right, so that being said, we have this column done. The next step is to repeat all of this process again. We need to find the most negative number in the bottom row, which is this one, which means this has become the new pivot column. Now again, from my previous video, you will have learned that you cannot use the same pivot column and the same pivot row twice. So we used this as a pivot column the first time around, so we can't use it again. Fine, we have this pivot column now, the first column. We used the first pivot row, the first row is the pivot row, which means now we have to use the second row as a pivot row. So let me get that highlighted here. This is the new pivot row, which means that this 1/2 here is the new pivot. So what I will do then to get a 1 in that position is we want to multiply s sub 2 by 2, and then we will put that new result in s sub 2 so we can have a 1 there. We need that 1 to be there in order for it to be the pivot. So we can find the entering and exiting variable. In fact, I guess we could do it right now. The entering variable will be x sub 1, and the exiting variable will be s sub 2, because we're going to essentially move this column here with the 1 in the middle of it, this basic variable column, to be under x sub 1. So here's row 2, or rather row S2 being multiplied by 2 from this one here. So we have our 1 where we need it to be, 1/4 turned into 1/2, negative 1 over 2,000 became negative 1 over 1,000, 1 became 2, 3 became 6. Pretty simple. So now the goal just becomes getting a 0 here and here. So the 2 row operations that will be necessary to do that are, let's see, negative 1/2 S2 plus x sub 2, and we will replace that that first row with this result, and then we will multiply s sub 2 by 2,000 plus p, and we will place that result back into row p. And so I will perform these 2 row operations, and I will display those on the next slide so you can see what that looks like. All right, so here is the resulting Simplex tableau. And I want to point out that the first 2 columns here used to be 1, 0, 0 and 0, 1, 0. And that means s sub 1 and s sub 2 used to be basic variables, but now the basic variables are x sub 1 and x sub 2. X sub 1 is the basic variable with a 1 in the first row. X sub 1 is the basic variable with 1 in the middle row, and p is still the basic variable with 1 in the bottom row. So what does this tell us? This last column gives us our answer every time if we're using the simplex method. What this is telling us is that x sub 2 is 9, x sub 1 is 6, and p is 300,000. So this means that a company should buy 9 primetime ads and 6 daytime ads, and they will reach a maximum of 300,000 potential customers. And I am going to be a big fat liar and say I'm going to cut this off after 1 example. If you want a second example, please view the other video that I, again, will link down there in the description for you so you can see another example of how this works. I hope this brings or sheds a little more light to the simplex method types of questions that you will encounter in your math career, and I wish you luck.